Okay, so what we'll do is we'll start with the powers. Remember, powers, exponents, index, all mean the same thing, right? So you'll see them, and so it's really important that you understand all the different ways that they can be presented to you, because you're going to see different words for different things in different usages. And one of the main reasons you're going to see these is not because you're going to have so many things to do with exponents on the exam, but an exponent is also how you get a logarithm, right? So you need to understand how the exponent rules work, because I saw many of you had problems with those simple problems where all you had to do was evaluate a logarithm. In order to evaluate a logarithm, you have to know the laws of exponents. But they're quite easy, all right? So what we're going to do is we're going to first just talk about the laws of exponents. Okay? Now, these don't really go in a 1, 2, 3 format because they're not built that way, but I'm going to put them that way anyway. First one, the most basic rule is that when you have an exponent, some a to the n, right? A is the base of the exponent. N is the exponent itself, right? And you'll remember that simply means to multiply the number times itself over and over and over and over again, right? So for example, 2 to the third power does not mean 2 times 3. It means 2 times what?
Times 2 times 2.
Exactly. 2 times itself over and over again, right? So that's the most basic idea of an exponent. So it's just a way of writing multiplication with the same number over and over again. But there are going to be some times when you get some exponents that behave differently, that behave in an odd way. And so that's what we want to talk about. First one we'll talk about is what happens if you have any number raised to the first power. Anything you have to the first power is just itself. Okay? So 3 to the first power is the same as just plain 3. And where this happens is a lot is you'll have a logarithm, log base 3 of 3. And you're thinking, what exponent would you put on a 3 to make it turn into itself? It's a 1, right? Another one that comes up a lot is when you have 0 as an exponent. 0 to anything to the 0 power always makes a what? Anybody remember? A 1, exactly. And it doesn't matter what it is, anything to the 0 power becomes a 1. So if you have if you're taking a logarithm and the argument is a 1, then that means that your exponent should have been a 0. Negative exponents give people some trouble. If you see a negative exponent, what that should be telling you is that the exponent and the base are in the wrong place. Okay? It literally means the reciprocal of. Do you remember what reciprocal? And reciprocal, it kind of means you're going to flip it over, but it really doesn't. So what it tells you is the base and exponent are on the wrong side of the fraction bar. So in other words, if it's a to the negative 1, so if I have a to the negative 1, it doesn't look like a fraction right now, does it? But it is, right? It's the same as saying it's over 1. So that tells me that a to the negative 1 shouldn't be in the top, it should be in the bottom. And when you move it across the fraction bar, notice that it changed the exponent from a negative to a positive. Okay? Now, we don't have anything left in the top, but we do, because what number was in front of the a, even if you don't see it? A 1. So it's 1 over a to the first. So, and then again, we're going to go through these laws, and then I'm going to go back and I'm going to talk to you about how they apply to the logarithms, because you can't understand logarithms without understanding these rules. Okay? Then we have something like a to the 1/2 power. Anytime you have a fractional exponent, that really means a radical, often known as a root. Right? So for example, 3 to the 1/2 power really means the square root of 3. So what if it was to the 3rd power? It would mean the cube root of 3. So if you had, and of course you can't take the square root of 3, so it doesn't really matter. Say you have like 5 to the 1/3 power. Still a root. The base is the argument. But this time it's the 3rd root. Right? So a fractional exponent just means a root. Okay? Let's see. So we did negatives. So I think we've covered them all. Now, and where that makes a big difference to you is if you understand the laws of exponents, then you can understand how to evaluate the logarithms. So those things kind of tie together. So let's look at that part next. And they do a beautiful job of it right there. I didn't see this. On page 20 in your book, you got the Walker Maths book. On page 20, they're talking about just that. So if you have log base b of 1 equals 0, okay, remember that whatever follows the equal symbol is the exponent, right? And anything to the 0 power has to be what number? 1. Be careful. Yeah, anything to the 0 power is always going to turn it into a 1. Right? Okay? So, if you have log base 10 of x equals 0, what that's really saying is 10 to the 0 equals what number? And 10 to the 0 is always equal to 1. Right? Anything to the 0 power is always equal to 1. So if you know the laws of exponents, then you can go backward using the logarithms. Okay? Let's see. So, for example, if it's a fractional power, that means you're taking a root. And when you take the root, what happens to the number? Does it get bigger or smaller? It gets smaller, right? So if you take the square root of 25, for example, what's the square root of 25? 5. So if the argument of your logarithm is getting smaller than the number you started with, then you know that means it's going to be a fraction as an exponent. So, for example, say you have log base 25 of 5 equals x. In other words, remember that means what exponent, because remember that's where the exponent is, what exponent would I put on a 25 to turn it into a 5? I'm not going to write all of these, but I'm going to write one of them. Okay? Now think about what's happening here. We started with what number? 25. And we want to turn it into a what? A 5. So is it getting bigger? It's getting smaller, right? Traditionally, exponents make numbers bigger, don't they? But this exponent that I'm looking for is going to make it smaller, right? And so the only way it can get smaller is if it is a fraction. Because the only way it can get smaller is if you're taking the root of it. Okay? So I'm looking for a fraction. Okay? And a fractional exponent always means a root. Now you don't know that it's the square root, but think about it like this. What root would I take of 25 to get a 5? That's a square root, right? So that means my exponent has to be a 1/2. Okay? Now, look at this example. Say I have log base, 7 of 1/7. So in this case, I'm taking a whole number and turning it into a what? A fraction. Well, the only way that I can take a whole number and turn it into a fraction is to use a negative exponent. Right? So, did I change the 7 to a new number? 7 is still a 7, isn't it? But it went from being 7 in the top to 7 where? In the bottom. So that tells me that it's 7 to the negative 1 power. Because remember, 7 to the negative 1 power means just drop it to the bottom. It becomes 1/7. So do you see that if you know what the exponents do, then you're going to know what kind of exponent to choose when you're evaluating the logarithms. So what if I have log base 10 of 1 equals x? What's the only exponent that would turn a 10 into a 1? A 0. Be careful, 0. 0 turns any number into 1, remember? Okay? All right? Now, and you can practice some of these and be able to do them. So really the logarithm section is the one where this makes the most sense as far as using it. Okay? But if you don't know the laws of exponents, then you cannot evaluate logarithms. Okay? So, let's go back to those exponents. Just a sec. Okay. What if I had an exponent on something and it stayed the same number? What's the only exponent that lets the number stay the same? 1. What kind of exponent turns something into a fraction? A negative. What kind of exponent turns something into a 1? 0. What kind of exponent makes a whole number turn into a smaller whole number? A fractional exponent, because it really means you're taking a root, right? And anytime you take the root of anything, you're going to get another whole number. So you see that if you know those laws of exponents, then you can bounce back and forth. So what I'd like to do is, I'm going to put a few logarithm problems up here for us to do together. All right? So you can kind of see, because evaluating logarithms was one of the skills that you had to do, and it didn't look so good when you did it, some of you. Okay? And you have that algebra test so you can see what kind of problems there were on there. So let's look at, I'm just going to pull a couple from the book, right? I'm going to give you a minute to work. Try it on your own, but if you can't get it, and use your notes there, but if you can't get it, then work together. But I want you to try them. Give them a shot, okay? All right, so let me see what we have. Just some simple basic logarithmic equations. It's just another way of thinking about things. All right, so well, that could be one of the reasons why you didn't do so well. There aren't any in here, are there? So y'all never practice this kind of thing? No. It makes me crazy. Okay, don't look at your book, because I'm going to write some that they have, and then I want you to... Okay. That makes me nuts. Yeah, don't look. because I want to see if you can do them. So what if I have log base 4 of 16 equals x? Now remember what each piece of that means. The 4 is the base. X means what exponent would you put on that base? And this is called the argument or the answer. I hate to say that, but the thing that you would get. So think about what exponent would you put on a 4 to turn it into a 16 is what they're asking. Okay, so what exponent, so what's happening is we're making a smaller number bigger, right? So that tells us it's just a positive whole number exponent. Okay? So you see the idea? We're taking a small number, making it bigger. That's just a regular exponent. And it happens to be what exponent? 4 to the second power would give you a 16, right? Okay? So do you see how knowing what exponents do to the number makes it easy to evaluate these? Okay? All right. So y'all can practice some of those. Just go back and look at some of those. What I'll do also is I'll look on Education Perfect and see if there's an exercise that does this kind of thing, and then you can go back and work on those too. Okay. Now, other than that, using powers, a couple of other things that you need to understand about working with exponents. That I saw some issues too. Okay. When you multiply with exponents, okay, remember if it's the same base, they have to be the same base in order to make this work. What you do is simply keep the base and add the exponents. All right? So for example, if you have x to the second times x to the fifth, that's the same as x to the 2 plus 5 or x to the 7th power, right? Okay, so even though it's multiplication, you actually add the exponents. What do you think about division then? Exactly. So you're going to keep the base and subtract the exponents. So if you have x to the 5 divided by x to the second, remember the fraction bar always indicates division. So that's x to the 5 minus 2, which is x to the 3rd power. The only place they can get weird on you is, what if I reverse that? X to the second gives us x to the negative 3. And is that a good answer? What is that negative exponent telling you? That it should be, yeah, it's in the wrong spot. It shouldn't be in the top, it should be in the bottom. So it's going to have 1 over x to the 3rd. Okay, don't leave negative exponents. Okay. So we talked about multiplying with the exponents and dividing with them, right? Okay. Fractional exponents, remember we talked a little bit about that. We said that fractional exponents are simply radicals or roots. Yeah, you'll call them roots or radicals. The symbol itself is actually the radical, but then taking it to the root, that's fine. Okay? All right. Surds. Never heard of that in my entire life. Is that what y'all call it? So on page 13, it says fractional powers, surds. I've never heard that term before. I love it. The radical term is called a surd. That's bizarre. That's too funny. I'm learning new things. Good. Okay? So you can practice some of those manipulations a little bit. Okay. All righty. All right. We've talked a little bit about logarithms. Remember, you're going to have logarithms. That changing an exponent into a logarithm and a logarithm back to the exponent is on your formulas page. So make sure. Pardon?
No, I'm just talking to myself. I started never saying this. I said we skip this whole topic. Pretty much did. Yeah. That's good. Oh, thanks for this. I feel really confident. Yeah. Because I give it famous. Yeah. That and I'm being honest. And it's not just because I'm dumb. Is this still only a fifth grade?
We'll take a break after this. Okay, application of exponential equations. This is that one where you had the house value and you were looking for the future value of the house. And so they gave you that formula, A equals PR to the N, right? And I think the biggest issue for most of you was not knowing, because they gave you the formula, but the biggest issue for most of you was not knowing which thing to put where. All right? And if it shows up again, it's not on your formulas page. You're just going to have to memorize it. Right? So this is one of those things you just need to memorize. Where P equals the starting value. Now, it's called P, the starting value, because P stands for, do you remember, the principal amount that you start with. Okay? R is the rate of change. So, and if you're talking about money, that means like the interest rate. Yeah? That's how it's changing. Okay? Then N is the number of time periods. And you have to be careful with this because it could say that the interest is calculated quarterly, which means how many time periods per year? 4. Annually? Semi-annually? Twice. Semi is twice. Okay. Biannual, the same difference, yeah. Monthly? 12, right? Okay. Your other months, yeah? Okay. So the number of time periods, very important that you convert those. And A, capital A, is the final amount. So be aware of which thing is which. And again, it doesn't show up in your formulas. You're just going to have to memorize which is which. And on both of those algebra ones y'all have done, there were questions like this. So if I was a betting kind of person, I would assume that it's going to happen again. Okay? All right. And so you're just going to have to put the right thing in the right spot. Okay? But you need to remember, okay, that you're looking for increases in value, decreases in value, but you're always doing a percentage. So if you're asked to calculate using this formula, in many of them you're just going to plug in the numbers and work it out. But in the ones where n is the unknown, okay, if n is not known, which is what y'all had, that means it's a logarithmic equation. You're looking for an unknown exponent. Your variable is in the exponent. That always indicates a logarithm. Right? Yes?
What is I in center?
What's what?
I in
If n, the letter n, my poor handwriting. So if n, the exponent, if the variable's in the exponent, but that's just the rule for everything. That's what logarithms do, right? If your variable is in the exponent, then you're always talking about using a what? A logarithm. Turns it into a logarithmic equation. Okay? All right. So let's just go through the example that they've given you so you can see where everything goes. Amanda borrows $100,000 from her parents so she can buy a house. So we need a P, we need an R, we need an N, we need an A, capital A for a final amount, right? If she borrowed $100,000, is that got the interest already built in? That's the starting point, the starting value, right? So that's always the P, right? So what if I paid $300,000 for a house, right? That's $300,000 I paid. Then I'm going to pay interest on top of that. So that's my start. So that's my starting value or the principal. Okay. They increase the amount she owes to them by 4% at the end of that year, and each subsequent year for as long as she owns the house. So in other words, they're charging her interest monthly. Semi-monthly, quarterly, this page 29. They increase the amount she owes them by 4% at the end of that year. So they're doing it per annum, they're doing it for years. So the period here is a 1 every year.
What?
Hey?
Is it 1.04?
I beg pardon?
Wait, no, okay. Yeah.
Yeah, but there's some more stuff in the formula we're going to do. We got to take N and times our P. Okay? Now. And each subsequent year is for as long as she owns the house. Amanda does not repay any of the initial amount that she borrowed. Okay, so she didn't pay any. Well, they call them points. She didn't pay anything in the beginning. Okay. So write an expression for the amount that she owes when she has had the money for N years. Now, here's what is a little weird for you. So the interest rate, remember, is 4%. But we can't work with a percent. We have to change that percent to a what? Decimal. So it's 0.04, right? So that's your rate. Okay. Now, but if you look at the formula where they have it in here, they've put the amount owed is $100,000 times 1.04.
It's plus interest, so it's 1,000 and the 4%.
Every time you charge interest, you're charging it's like you've added the interest into the amount of money that you owed.
And that's 1,104,000.
So, exactly. So, this one part, do you see this one that's in there? That's never given to you. You just have to remember that the amount of interest you pay is going to be, the rate you pay is based on the amount that you owe, right? So you're going to have that whole amount plus 4 with 4 more percent. Okay? All right, so make sure that you remember to add the 1 in. Then when you're finished with the problem, guess what you have to do? So, okay. So there's how they're getting that PR part. It's the principal times the rate, and the rate is just the decimal percent plus 1. And that plus 1 is always there. Okay? Because you're increasing the amount. Yeah. If you're going down, then yeah, we don't need it. Right? Did they give you a decreased one? I don't think so. I think every time they did was they increased it. They did on the test? Did they? I did that. Yeah. You just don't use the 1. All right. Yeah. So you subtract it away from it. You wouldn't add it to it. Okay. All right. Do you want to take a little break? So, if you're talking about an increase, so in other words, if you are paying, if the amount you owe is going to go up because of the interest, if you're talking about the increase, then you're going to add the interest to 1. But if you're talking about a decrease, and again, there weren't any decrease ones on the tests, that doesn't mean they can't show up. Decrease, pretty easy though. If you're going to add to 1 for an increase, what do you think you're going to do when you decrease?
Subtract.
Yeah, subtract the interest from 1. So, you've got to memorize what the pieces are, and you have to know, is it increasing or is it decreasing? Because that's going to determine your rate. The R, the rate of change. Okay? And then after that, it's simply a matter of solving the equation. So, and notice they didn't multiply that out, because then you'd have to just divide it out again. It says at the end of the amount she owed 150. That's where that big amount came from. So if you don't multiply this out, but just isolate it, and you isolate by doing the opposite. So if it's connected with multiplication, what's the opposite of multiply? Divide. So just divide both sides by the 100,000. So try to make your life as simple as possible. That just gets you the base and the exponent on one side. And then all the plain old numbers on the other. Okay. And if the exponent is in the variable, is in the exponent, that means you need to change it into a logarithm. But this is one of those simple ones where if you have just two things, one thing on either side, all you need to do is take the logarithm of both sides. Right? So taking the logarithm of 1.04 to the n, taking the logarithm of 1.5. Remember, once you take the logarithm, what happens to the exponent? What can you do with it? You just drop it to the front. Remember that funny rule of logarithms? And again, you don't have to memorize that, I don't think, because I think that one is also in your formulas page. We'll look to make sure. And we're trying to get the n by itself. How is that n connected to the rest of that stuff? If they're just side by side like that, that means what operation? It means times, multiplication. And the opposite of multiply is divide. So we'll simply divide away the stuff we don't want. And what we don't want is the logarithm of 1.04. So it'll divide away over here and give me my n. And over there, all I have to do is put that into the calculator. Right? To find out what those are. So 10.3380 years. They rounded it to 4 decimal places. Okay? All right. So that was one of the ones where there was a lot of issue, and I think it again was because you didn't know what to do with these, and you didn't know increase or decrease part for the rate. So easy things to fix, but you've got to really study it to make sure. Okay? So if I say A, stop that. Final amount. R, the rate of change. But rate of change can be an increase, which means what? I need to add 1, Rate of change can be a decrease, which means I need to take it away from 1. Okay? So keep that in mind, increase or decrease. All right? P, starting value. Okay? N, the number of periods, right? Okay? 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 All right.
Is this going to be like put on OneNote?
Yes, I'm going to put the video on OneNote. Okay?